All right, we are given a function f of x. So the name of this function is f of x. All right, it's the function's name is f. It varies with respect to the variable x. So what does this f of x mean? This means give me some input x, and the rule that f is going to apply to it is that it's going to double whatever input you give it to it and then add 1 to it. So this f of x, that's really the output that we get, such that when we input some number x, we will double it, add 1, and that's going to give us our output. So that's sort of the rule that this f of x has. So each function has a different rule. This one just happens to take everything that you give it to it, doubles it and adds 1 to it and provides you with an output. But each function has different rules. So what does it mean to evaluate f at a particular number? Or in other case, in other words, what does it mean to find f of 2, for example? Well, this is the rule that we use to find f at any number x. To find f of 2 means everywhere there used to be an x, you're going to plug in 2 instead. So substitute the x with a 2. This is the same thing as saying that the input that you give to f is 2. So what is the output when the input is 2? Well, I'm going to double the 2 and add 1 to it. So that's the same thing as saying that I'm going to take my f of 2. That's the same thing as saying, okay, I'm going to take the rule of f, so that's 2 times whatever the input is, but now the input is 2, and then plus 1 to give me 5. So now if I have f of 2 equals to 5, that means a few different things. First, notice, where it used to be an x, now I replace that with a 2. So this 2 over here, that's my x value. That's really my x value. So when my x was 2, my f of x ended up being 5. That's my y value. So when x is 2, my y value is 5. So this over here is my y value of 5. And there's another way for us to think about what f of 2 equals to 5 means. That also is an ordered pair on a graph. So this is equivalent to the point 2, 5. Because remember, the point 2, 5 on a graph means the x-coordinate is 2 and the y-coordinate is 5, meaning for the input of 2, we receive the output to be 5, which is a point on the particular graph. So this is what it means to evaluate a function. The answer is pretty much 5, right? Because we were given the problem to find the f of 2, and we found that it's actually 5. But I wanted to make sure that we understand what that 5 is. That's the y-coordinate that corresponds to the x-coordinate of 2 in this function f of x. All right, so very similarly, we are asked to find, to evaluate f of negative 1 in part B. So that's the same thing. That's the same thing as finding f of negative 1, which means I'm going to look at my function f, and anywhere I see an x, I'm replacing that now with negative 1. So that's going to be 2 times negative 1 plus 1. So that gives me negative 2 plus 1, which is negative 1. So what I did is I found out that f of negative 1 is negative 1. This means that when x is negative 1, my output, or my y value, is also negative 1, which is equivalent to a point on the graph of negative 1, negative 1, which is a point that belongs to the function f of x. In this case, we have a function that's called h, and this function varies with respect to the variable x. So the rule of the function h is that give it some input, any input x, and what is h going to do to it? It's going to negate it and then subtract 1 from it. So no matter what function you feed the h, it's going to negate it and then subtract 1 from it. Now, in part A, we are asked to find h of m. So in the previous example, we had a number, but now we have a letter. But again, it doesn't matter. This basically just means, okay, everywhere there used to be an x before, we're going to replace that with m instead. So then how is that going to look like? Well, h of m is going to be negative m minus 1. And that's it. That's the answer already, because there's no way that we can simplify any further, and there's no way to rewrite it. So this is already it. That's what h of m is. For part B, we are asked to find h of negative k instead. Again, what that means is that anywhere there used to be an x before, Now I'm plugging in negative k. So literally everywhere you see an x, you just replace that with negative k. So let's go ahead and do that. So my function starts with a negative, but then I see an x. I'm replacing that x with negative k. And then you still have a negative 1 in there. Now if I am going to simplify this, this is going to give me a positive k minus 1, and then that's already our answer as simplified as possible. In this case, we have a function g of x. So our function g varies with respect to x, meaning give it some input x, and g is going to vary depending on what we feed it. So give it some input x, and g is going to square it, negate it, and subtract 5 from it. And then it's going to provide us with that output. So to evaluate g of 2 literally means everywhere you see an x, replace that with a 2. So that's going to be, let's see, so g of 2 is going to be, let's see, it starts out with a negative. Now I see that x, so the x is 2, and then I'm squaring it, and then minus 5. So be careful, that x is outside of the squaring, not inside, so it stays there. So I've got a negative, and then 2 squared is 4, and then minus 5 gives us negative 9. So that is already the answer, right? When our input was a 2, the output is negative 9. This is the same thing as saying when x is 2, y is negative 9. And it's also the same thing as saying that this is a point on the graph, 2 comma negative 9. So just remember that this is the same thing as saying that when the input is 2, the output is negative 9, or the same thing as saying that when x is 2, y is negative 9. So that's what that means, what we just found out. And let's look at part B. Part B is asking us to evaluate g of negative x. What this means is that, again, we're looking back here. Everywhere there used to be an x before, we are now replacing that with negative x. So anywhere you see an x, you literally just replace it with negative x. So we're going to have, let's see, negative. Now here's the first x that I'm seeing. I'm replacing that with negative x. And then that becomes squared, and then minus 5. Now let's clean it up a little bit. I still have the negative on the outside, but the negative from the inside gets squared. So I just have a positive x squared remaining, and then minus 5. And then let's see if we can possibly, actually, we cannot even simplify it any further. So it stays at minus x squared minus 5. So that would be already our answer. We have a function g here, and g varies with respect to x, meaning give it some input x, g is going to take 3 minus double that input, and it's going to provide us some input. Now, to evaluate g of x plus h means, okay, look at the rule for g, and anywhere you see an x, you literally replace that with x plus h. So let's go ahead and do that. So g of x plus h just means start off with g. G starts off with 3 minus 2 times. Now let's be careful. There used to be an x right here. Now I'm going to replace that x with x plus h. Now be careful, you absolutely need the parentheses over there because the entire quantity x plus h gets doubled by this 2 in front of the parentheses. So let's clean it up a little. So we've got 3 minus 2x minus 2h just by distributing that negative 2, and it looks like that's as simplified as we can get it. And let's look at the second part. The second part is something very similar. Everywhere there used to be an x, I'm going to replace it with 2x plus h instead. So again, I'm starting off with just g, and g starts with what? It starts with 3 minus 2 times. Now, where there used to be an x, now I'm replacing it with 2x plus h. So that becomes 2x plus h. So then to clean it up, we just have 3 minus 4x minus 2h. And again, I think that's about as simplified as we can get it. So then that would be our answer.